Okay, so if you remember, we were talking about the derivative of exponential functions. We haven't finalized that yet. What our question was, what is the derivative of a function of this form? We haven't found that yet, but we found that the derivative of e to power x is equal to the function itself, and we learned that e to power c times x, if I want to differentiate it, c goes down, and then it will be multiplied by this. Okay, but to be able to finalize our discussion that we start 2 sessions back and finally answer a to power x, what is the derivative of this? We need the notion of the natural logarithm. And then last time, the last part of the last session, I started introducing you the notion of the natural logarithm. And that's very simple. So that is not something new at all. The only thing that you need to know about this is that if you have a logarithm whose base is the Euler number, so Euler number, we realize that this is approximately 2.72. And that's a famous constant in mathematics. If you take this number as the base of the logarithm, instead of writing this form and saying logarithm of a in base e, we just simply summarize it and write ln of a, and this is called the natural logarithm of a. But again, because a is in front of a log, that number should be positive exactly like any other logs. So this means that when you talk about ln of a number, that number should be a positive real number. Ln of 0 is not defined. Ln of a negative number like ln of -2 is not defined. And then because this is ln, this ln is just a logarithm, so it enjoys all the properties, standard properties of logarithm. And if you remember, we started translating all those formulas for logarithms into ln language. And these are the formulas that we had so far. So if a is positive, so this is very important for our purpose for this lesson. We learned that if a is positive, e to the ln of a is equal to a itself. Ln of 1 is 0. Ln of e is 1. And then we realize that if x and y are positive numbers, ln of the product x times y becomes ln of the first one plus ln of the second one. So ln actually transforms a product to a sum. And ln also transforms a fraction, a division, to subtraction. And then we also learned that if I have ln of x to some number, that number can go behind the ln and can be multiplied by the ln of x itself. Of course, the condition is that x should be positive, but for p, we do not have any conditions. P can be any number. Okay, but I didn't find any time to give you some examples. But let me now start doing some examples today, okay? And then, of course, we have to continue and finally finalize the problem of finding the derivative of an arbitrary exponential function, as we started 2 sessions back, actually. Okay, so let me write example here. Yeah, because I cannot see if you chat on the chat window. Please, if you have any questions, interrupt me just as normal as you do in the normal lesson. So example, simply without using a calculator, simplify each item. Okay, so number one, These are very simple stuff, so I just do them quickly myself. So ln of e squared, okay? So what we can do, so I will change to green. Green is the solution. So if I want to solve this problem, so you see that I can immediately use the last property. I have a power here, I have an exponent here. These exponents go here, okay? So this becomes 2 ln of e. But what is ln of e? This is the third property. So ln of e is just 1. So this becomes 2 times 1. And the answer is simply 2. Yes? So let us do number 2 here to save some space. So number 2, ln of the third root of e. Okay, so hopefully you have enough experience to know what to do here. So what I can do, I can write ln, but for the third root of e, I can write it as an exponent as e to power a third, and then I can use the same rule. According to this rule again, this 1/3 goes behind the ln, so this becomes 1/3 ln of e, and then ln of e is again 1, so it becomes 1/3 times 1, and this becomes 1/3. Yes, yeah, these are very simple questions, but I think they are necessary to know, and I want to make sure that you actually can do it. So number 2, number 3, sorry, number 3, what happens if we have this situation, for example, e to power ln of 3? Yes. Okay, it's completely clear that I can use immediately this formula. If this combination, you need to have it in mind. Okay, e to ln of some number, everything can be eliminated and a is left. Of course, this a should be positive. In this case, 3 is positive, so everything is okay. So this is just simply, if this is given to you, you can just simply write 3 as the answer. Okay, so number 4, what happens if we have this situation, e to power 2 ln of 3? Yes, so we want to solve this problem. Okay, immediately we cannot use any of these formulas. So, because you see that if you want to use this formula, there shouldn't be any number behind this ln, yes? Or if you want, that number is 1, but here this number is 2. You can solve it in 2 different ways here. One way that I myself prefer is to do this. I would write e, but of course, this equality is, this is an equality, so it means that if I need, instead of this, I can write this. And sometimes if this is given and I need, I can write this. So it means that if I have an exponent here, I can move it to the back. Or if I have a number here, if I need, I can put it on top here. It depends on the problem that you are solving. Here, the second one is actually relevant. So what I do, I will write ln of 3, and then I will take this 2 and move it on top of 3 here. So this becomes ln of 3 to power 2. But 3 to power 2 has a better name, and that is 9. And now everything is in order. So now I can use this formula. E to power ln of 9 becomes simply 9. Yes, so this is one way of solving the problem. Another way that's also instructive, so let me change the color, write it with another one. So you can do it in this way. So you can write this one is equal to e to power ln of 3, and then raise it to power 2. Yes. Why this is true? Because if I have an exponent and I exponentiate it once more, I can multiply these two numbers. If I multiply these two numbers, I will get the same thing back. But now what happens? E to power ln of 3 is exactly this formula. So this gives me a 3. But now I have a 2 on top of that. So 3 to power 2 becomes 9. So it doesn't matter if you solve the problem like this or that. But I prefer the first one. So here, this problem is finished here. So either you can use this or you can use this. But not you don't need to write them both. So this is important. By the way, both of them is important to know, but I myself prefer the green one. Okay. And number 5. So what happens if I have this situation, e to power minus ln of 5? So what can I do here? Still, I cannot immediately use this formula, because in this formula there is no negative sign, but I have a negative sign here. Okay, but the idea is exactly the same, and let me just solve it in one way. Okay, so you can solve it in the other way if you like to. Okay, so this becomes equal to, so what should I do? I would write 1. First of all, this minus sign, you need to interpret it for yourself. It is this ln of 5. Okay, let me solve this one in 2 different ways again. So this is one way, and then I move this minus 1 on top of this. So then it becomes e to power ln of 5 to power minus 1, which is e to power of ln of 1 over 5, because 5 to power minus 1 means 1 over 5. And now everything is in order, so the answer becomes 1 over 5. So here, this is one way of solving the problem. Yes. Another way of solving the problem would be you start with negative power. So I have a negative exponent here. What I can do, I can write 1 over, and then I can write e to power positive ln of 5. But now numerator is just 1. The denominator is also simple. I can use this formula. So the answer immediately becomes 1 over 5, and then I am done. So it's up to you which one you want to use. Both of them gives the correct answer, actually. Okay, and then I can write one more here. So number 6. So let me write number 6 here. For example, e to power minus 3 ln of 3. So if I want to solve this one, I can use the same trick. So let me just use the second method here. So I see a negative exponent, so I will write 1 over, and then I make the exponent positive. Yes? And now I can write this as 1 over. I think this is not very useful to do this in this way, because let me just do it in the first form. So I will take minus 3 up. Yes, I will take this minus 3 and put it on top of this one. So this becomes e to power ln of 3 to power minus 3. But 3 to power minus 3 is 1 over 27. And that's the answer is 1 over 27. Okay, so hopefully you understand why. So 3 to power minus 3 is 1 over 3 to power 3, and this is 1 over 27. Okay, so that is one type of problems that you need to know about this combination of the Euler number and the natural logarithm. Another type of problems are equations. Okay, so let me just give you another example. Solve the following equations. Okay, so number 1, we want to find x. Let me start with very simple one. ln of x is equal to minus 2, and I want to solve that. By the way, it might be I have forgotten to write the most important relation here. So if you remember, what was the meaning? If I say ln of x is equal to a number a, what does this mean? This means that e to power a is equal to x. So that is the meaning of this ln, yes? So this is important to remember this fact. This is coming from the definition of the logarithm, okay? So now you want to solve this equation and find x. And that is very easy. So you would say that ln of x is equal to -2. This implies that e to power -2 is x. So I am done. This is my x. So x is equal to 1 over e squared. If you want to, you can just put this number in your calculator and find the approximate value. But when I don't mention it, you need to keep it in exact form. So this is the answer to this equation. Is that clear?
Yes.
Okay, so let us go to the next one. So number 2. So number 2, I want to solve this equation. Very simple one first. E to power x is equal to 7. Okay, so how can I solve this equation? So I need to remind myself of this formula. You see, sometimes this one is given to you, and to find x, you need to go in this direction. Sometimes the exponential form is given to you, and the unknown is in your exponent, and you want to find your unknown, which is your exponent. You need to go in this direction. Okay, so this is one of those problems. So if I want to answer this question, I would say that, okay, e to power x is equal to 7. Then this means that x is ln of 7. As simple as that. So that is the answer to this problem. And if you want to find an approximate value, you need to put this number in the calculator. I already mentioned that you need to go and find the ln button on your calculator. So there is a number, there is ln button on your calculator, there is log button on the calculator. This is the natural logarithm, and this is the logarithm in base 10. And there is a pi button on the calculator, and there is an e button on the calculator. So you need to find all of these in your calculator too, and be able to use them properly. Okay, so let us make this problem a little bit more interesting. So number 3, I want to find x such that ln of 2x plus 3 is equal to -1. Okay, so if I want to solve this, what I do, I would write ln of 2x plus 3 is -1. Then this implies that, what can I conclude from here? How should I go? Do you know? What is the first step at least? Okay, so let me describe it. I don't know, because I told you that if L, so let me write it again here. So let me repeat it with a different color here. So if ln of something that you don't know is equal to something else, then immediately you can conclude what is inside the box is equal to e to power what is inside in your circle. This is something that is helpful, a schematic to help you to remember what to do. So now here, this is going to play the role of my box, which I don't know because I don't know x, and this is the circle, yes? So if I use this rule, then it becomes clear that what is the answer. So 2x plus 3 is equal to e to power -1. But I am looking for x, so what happens? So 2x becomes e to power -1 minus 3, and then what happens is that x is equal to e to power -1 minus 3 divided by 2. Of course, that's correct, but if you want to get rid of this negative power, you can multiply the numerator and the denominator by e. If I multiply e in the numerator, e times e to power minus 1 becomes e to power 0, which is 1. And the next one becomes 3e. So then it becomes 1 minus 3e divided by 2e. Okay, so that is the answer that you get. But of course, before accepting this answer, you need to be careful that this is possible. So it means that you need to check this number here to see that if this is going to be negative or positive. But this is not negative. Yes, it is not that hard to check that if you put there. So let me just do it. So if I multiply this number by 2, yes, and add 3 to it, let us see what happens. This 2 and this 2 will gone, so I will be left with 1 minus 3e divided by e plus 3. And if I take the common denominator, it becomes 1 minus 3e plus 3e. So it becomes 1 over e, and that is positive. So this answer is acceptable. So remember, if you remember from Math 2C, when we were solving the root equations, you need to be careful. Might be there is a false root coming out. So you need to detect that. And the same is true for logarithmic equations. Sometimes you solve a logarithmic equation and the answer that you get is a fake root, actually, is a false root. So you shouldn't accept that one at the end. Okay, so this is another type of problem. So let me go to one more example. Here, number 4, we want to solve this equation. 4e to power x over 3 is equal to 28. Okay, I want to solve this one. How should I solve this one? I would say that 4e to power x over 3 is 28. First, I divide everything by 4. The left-hand side becomes e to power x over 3. The right-hand side becomes 7. And this is the standard form. You see, this relation is also in the other direction. So you can also go in the other direction, but let me write it in this way. If you have e to power a question mark equals to square, if you want to find the question mark, the circle is ln of this box. Okay, I don't want you to learn it in that way, but hopefully you understand what is the meaning of these things. So here, this is playing the role of your unknown. So e to power something that you don't know is equal to 7. So this shouldn't be hard for you to conclude immediately that x to the 3 is ln of 7. But I am looking for x, so I multiply everything by 3. The left-hand side becomes x. The right-hand side becomes 3 ln of 7. You can keep it in this way. This is also acceptable, so you can just keep it like this. Or sometimes if you want to, you can move this 3 and put it on top of 7. And then 7 to power 3 is 343. So it doesn't matter. Sometimes you check the answer in the faucet. It is not written in this form. So you need to also understand that these are the same thing, yes? To 343. So that is also correct. So here it doesn't matter. As far as you find one of these, that's okay. Okay, so these are the same things. Okay, now, for example, let us go to another problem, number 5. You want to solve this equation. E to power 2x plus 6 is equal to 5 e to power x. Okay, do you have any idea how to solve this one? No ideas? Can you hear me? Yes? Yes or no?
Yeah, we
Hello?
can.
Okay,
We can
okay.
hear you.
Okay, it was a complete silence from your side. I thought that might be there's a disconnection. Okay, any ideas? So here the notion of the auxiliary variable will help you, okay? So if you remember a little bit from your previous studies, so I would say let e to power x be some variable, let us call it t, yes? Then e to power x to power 2 becomes equal to t squared, yes? So if I say that then the name of e to power x is t, I can raise both sides to the second power and I will get this. But the left-hand side, what does this mean? E to power x to power 2, I multiply the exponent, so it becomes e to power 2x is equal to t squared. Okay? So therefore, the equation that I have, which is e to power 2x plus 6 equals to 5e to power x, actually becomes a new equation. And not a new equation in a new form. Okay, so instead of e to power 2x, I can write t squared. And instead of e to power x, I can write t. Yes, so what happens? It becomes t squared plus 6 is equal to 5t. But now this equation is completely trivial. This is a quadratic equation, so you know how to solve that. So I move 5t to the left, it becomes minus 5t plus 6 equals to 0. And then we can use the PQ formula or ABC formula to solve this problem. But now, because you are studying Math 3C, you are more experienced, so hopefully you remember how to factorize this. So you open two pairs of brackets, put a t here and there, and then you ask yourself, I need two numbers whose sum is equal to this and whose product is equal to this. Yes, so what are those numbers? It is clear, yes? One of them is minus 2, the other is minus 3. If I add them, it becomes minus 5. If I multiply them, it becomes positive 6. I put one of them, for example, minus 2 here, the other one here, okay? So this becomes minus 2. If you don't like this method, you can just PQ, you can use PQ formula. But then this zero product rule comes to my help. The product of two numbers is equal to 0. This is not possible unless at least one of them is equal to 0. So this means that t minus 2 is equal to 0 or t minus 3 is equal to 0. The first one gives me t equal to 2. The second one gives me t equal to 3. But my point is not to find t. My point is to find x. But I know the relation between t and x. So I would write t is equal to 2 means, if I put it here in this equation, this means that e to power x is equal to 2. Based on what we learned, x is just simply ln of 2. So this is one answer that you get here. But another scenario is that t is equal to 3. Then this means that e to power x is equal to 3. So then you get x is equal to ln of 3. So that is the second answer here. Okay, so that is also something I want you to know. Yeah, let me solve another example for you. So how we solve this equation, ln 3 times ln of x is equal to ln of 5. Oh, sorry, let me write it in this way, ln of 5x. By the way, people just simply write ln of 5x. There is no matter of confusion here, but if you want, you can put a pair of brackets around them. Okay, but this is the way that you see it in literature. Oops, I need to change this color to be consistent. So 3 ln of x. So do you have any idea how to solve this problem?
We can first put 3 to the power of x to the power of 3.
Yes, this is one way of doing that. So if I think if I recognize your voice, you are Martin, yes. So we can use that. So let me write method 1. That is not what I wanted to do, but that's also okay. So let me write here. So method 1. Okay, so Martin told that we can put this 3 which is here on top here. That's okay. So then what happens? Then this becomes ln of x to the 3 equals to ln of 5x. Okay, then what can you yourself continue?
With the right side we change to the left side.
You mean that I move this one to the
Yeah,
left
move it to
side?
the left side. 5x.
Okay. But you don't, so if you do this, you don't need to do that. That's also correct, but let us make it easier. So let me write something here for you.
Mm.
If you have ln of a box equals to ln of something else, this has this property that if the ln of two numbers are equal, so you can conclude that these numbers are also equal. So this is good to know. Okay, so here, this is the same story. Here, this is the box, and this is the circle. I am not saying what you said is wrong, but I would start, I will stop, I will continue from here, because now ln of something is equal to ln of something else. I can immediately conclude that x to the 3 is equal to 5x. Then I move this to the left-hand side. Even in that case, that also works fine. If you want, I can continue your way as well. But then this becomes 0, and then what I do, I factor an x out. X squared minus 5 is equal to 0. Then by the 0 product rule, this gives me either the first one is 0 or the second one is 0. So the second one is 0 means x squared minus 5 is equal to 0. So this means that either x is equal to 0 or x squared is 5. But x squared is 5 gives me 2 more, yes? So this finally gives me x is equal to 0 or x is equal to a square root of 5 or x is equal to minus square root of 5. But if you stop here, that is not complete solution of this problem. Do you think that all of these are acceptable? Clearly not, yes, because 0 is not acceptable, because I told you that in front of an ln, in front of every ln, there should be a positive number. 0 is not positive. So if I put x equal to 0 here, this becomes ln of 0, which is not defined. So this is not acceptable. But what about this one? This one is not acceptable either, yes, because in front of ln there should be a positive number, but minus the square root of 5 is negative. So this means that these are not acceptable solutions. So I cross this and I cross this. But the square root of 5 is acceptable both here and there, because here is acceptable, square root of 5 is positive. Here, if I multiply it by 5, again it is positive. So the answer that I get is this one only. X is equal to square root of 5. This is the only answer that you get, yes? Okay, but now let me just try to say what Martin said. So Martin said that we can take it, might be this is also somehow easy, good, that's also good. So Martin told that we do this, and I think he will continue by writing division, yes? Is that right?
Yes. Yes.
Yes. Also, you divide this and then it becomes 0. That's also a very good method, yes. Why this is the case? Because we have the ln, the difference of two ln's. If you remember, the difference of two ln's can be written as the ln of this division. And then this x and that x cancel, so I will have ln of x squared divided by 5 equals to 0. Okay? And then what does it mean? The ln of a number is 0. So what that number is, that number should be 1. Yes? And then you see that you get x squared is equal to 5, and then you get 2 roots plus or minus square root of 5. But of course, minus the square root of 5 is not acceptable, but you get this square root of 5 again. But you don't see any track of 0, but that's no problem because 0 was not a solution in the first place. Okay, so this I will call method 1. But here I wanted to do it in a different way, so let me write method 2. Here for me it was easier to expand instead of collect, okay? So I think it's good to see which method is suitable, more suitable for the problem. So let me write the problem again here in front of your eyes. So 3 ln of x is equal to ln of 5x. So I would prefer to write it in this way. Ln of x, instead of 5x, I write ln of 5 plus ln of x. Okay, so that's also the same story. Then what I do, I move this to the left. This is 3 ln of x minus ln of x. It becomes 2 ln of x is equal to ln of 5. Is that understandable? So I have the formula that if I have ln of a times b, I can write it as ln of the first one plus ln of the second one. I use that formula here. So I wrote the ln of the first one plus the ln of the second. Then I move this to the left. It becomes minus ln of x. I have 3 ln of x here, minus 1 ln of x, it becomes 2 ln of x. Now I put this 2 on top of x. I write it ln of x squared is ln of 5. Then this means x squared should be 5, and the same story. Okay, so I don't continue. So if you continue, finally you get only one acceptable solution. So that's also possible. That's up to you which one you want to choose. Okay. Let me give you another example. So which number was that? Number 6, number 7. So 5 ln of x is equal to ln of x squared plus 6. Okay, so I just want to write one more and wait. So I will write 3 more and I want to wait for you, okay? So problem number 7, problem number 8, 4 e to power minus 3x plus 1 divided by 2 equals to 7. And finally, number 9, ln of x plus 1 plus 2 ln of a square root of, so let me make it clean, square root of x plus 3, and then I have equals to 2 ln of x. Okay, so I will pause the video. I think I can wait for 10 minutes, and then I want you to solve them. I will come back and solve them, and then I will continue the lesson.
Alden, I think your microphone is muted.
Thank you very much. Now you can hear me now?
Yep.
Okay. So here I want to solve this problem. I will solve it in a way, because I told you that I want to finalize this lesson. So let me start solving the problem. If your answer matches with my answer and you're sure about your own way, that's okay. But otherwise, you can ask me a question if you doubt if that method also works or not. Okay, but the way that I use this to solve this problem, I keep 5 ln of x as it is. And then I will take this 2 from here to here. So this becomes 2 ln of x plus 6. Okay, and then I move 2 ln of x to the left. So it becomes 5 ln of x minus 2 ln of x equals to 6. Then it becomes 3 ln of x is 6. I divide by 3. Ln of x becomes 2. And then this means that x is e to power 2. So this is the answer that you are supposed to find. Might be you have raised this to here and then move this to the left and then have used the division rule. That's also correct. But this is one way. And of course, I don't have any problem here because this is a positive number. So this is positive. This is also positive. So no problems. For the next problem, I prefer to get rid of fractions immediately. So I multiply everything by 2 first. So then the left-hand side becomes this. The right-hand side becomes simply 14. Then I move 1 to the right. So it becomes 4e to power minus 3x is equal to 13. Then I divide by 4. It becomes 13 over 4. Then I would realize that minus 3x, which is the unknown exponent on top of e, becomes ln of this number. I am looking for x, so I divide by minus 3, or in other words, I multiply by minus 1 over 3. So it becomes minus 1 over 3, ln of 13 over 4. This is the exact value. I want you to keep the exact value unless it is explicitly mentioned in the problem itself. So that's answer to this problem. And finally, the last one, I don't know, you need to collect the terms somehow. So I would raise this one here on top of this one. I will put 2 here on top of this one. So let us do it in 2 steps. So this becomes ln of x plus 1 plus ln of a square root of x plus 3. Then I put a power of 2 here. On the right hand side, I also write ln of x squared. But of course, this power of 2 here will actually cancel this square root. So I will have ln of x plus 1 plus ln of x plus 3 is equal to ln of x squared. But the left-hand side can be collected as the ln of the product. So it becomes the ln of x plus 1. You don't need to write that extra pair of brackets. So I just write ln of x plus 1 times x plus 3. On the right-hand side, I will have ln of x squared. So do you remember what I told you here? If ln of a number is equal to ln of another number, then you can conclude that the numbers are equal. So this is happening here. The ln of one number is equal to ln of the other number. So I can conclude that x plus 1 times x plus 3 is actually x squared. And then this is a normal equation. So I expand it. It becomes x squared plus 3x plus x plus 3. On the right-hand side, I will have x squared. If I collect the terms, it becomes x squared plus 4x plus 3 is equal to x squared. Now what happens? This x squared, move it to the left, will cancel. This is x squared. So then what I do, I move 3 to the, so it becomes 4x plus 3 equals to 0. So this means that 4x is equal to minus 3. So this means that x is equal to minus 3 over 4. But this answer is not acceptable at all, yes, because you see that this number it is acceptable here because if I add 1 to it, it becomes positive, so I don't have any problem here. If I add 3 to it, this becomes positive, no problem here, but I will have the problem here. This is a negative number, I cannot put it here, so this is not acceptable. And so that is not acceptable, I will cross it over. So then what is the answer to this problem? You need to write this equation does not have any solutions. Okay, so there is no solutions for this equation. Okay, now let us back to our main problem. So let me write this here. So the question was this: I have a function f of x equals to a to power x. I know that a is positive. My question is that what is the derivative of this function? Okay, so let me write what we have so far. We know that if we have e to power x, the derivative is e to power x. We also know that if I have e to power a constant times x, the derivative constant goes down and then it becomes e to power cx. Another thing that we know from the first session of this series of lectures, we know that I don't know. So we know that f prime of x, do you remember, is a to power x multiplied by a limit. The limit was of this form. So if you go and watch the videos or you look back at your notes, we had this so far. So we know we have partially answered this question. We know that the derivative of this function is the same function but multiplied by a limit. We don't know about this limit unless a is e. So we know that if we have this limit is 1. But for other numbers, still we don't know that. Okay, so these are the things that we have so far. Okay, now how can I calculate this limit? If I want to calculate this limit, if I want to calculate this derivative, what I should do is this. I would say that f of x is equal to a to power x. But instead of a, I write e to power ln of a, and then I put a power of x. So you see, this x is just this x I copied and pasted. Instead of a, I wrote e to power ln of a. So that is one important property of ln's, yes? Okay, now what happens here? If I multiply these two, this is an exponent. I am exponentiated with x once more. So the rule of exponents would apply. So this becomes e to power ln of a multiplied by x. So it's very nice. There is no difference between this function and this function. My goal is to find the derivative of this function. So therefore, the derivative of a to power x that I am looking for is equal to the derivative of this function. Yes, but we already know how to differentiate this function. Look here, if I have e to power a constant multiplied by x, we already showed that its derivative c goes down, and then I repeat my function. So I will do the same thing, but here, this ln of a is playing the role of the constant c, yes? So this c goes down, ln of a goes down, then I have to repeat the same function in front. Now, if I ask you, Can I write this now in a simple form? Yes, because you see this is the same expression, but this is equal to a to power x itself. So this is exactly a to power x. So I put it back. So this becomes ln of a multiplied by a to power of x finally. So this is our derivative. The derivative of e to power x is more or less the same function itself, but you need to multiply it by an extra factor of ln of a. So this is the formula that we got here. Okay, is that understandable?
Yes.
So the logic was that my question was to find the derivative of this one. First, we couldn't do this directly. We found the derivative of this function for a very particular number, the Euler number. And now introducing the natural logarithm, and then the derivative of this that we have already found, we were able finally to answer this question. So what is the derivative of the exponential function a to the x? The answer is a to the x times ln of a. By the way, if I ask you what is this one, you can also use this rule. Yes, it becomes the same function multiplied by ln of e, but ln of e is just 1, so you get the formula back. So this is one thing. Another one that is written in the book, what happens if I want to go further? Before going further, let me just tell you something here. Now, if you compare this formula with this formula, you can immediately realize what this limit is. Yes, because f prime of x is the derivative of a to the x, so I can write a to the x prime. This one, in the first session, we learned that this is the same function multiplied by this limit. Now, I get the formula is the same function multiplied by ln of a. So if you compare these two formulas, you also get a very nice formula, yes? So you will get this fact. Let me write it with some other color here. If a is positive, then the limit of a to power h minus 1 divided by h when h goes to 0 is equal to ln of a. So this is actually very strange, yes, because usually we calculate limits to answer derivatives. I always draw this, I don't know. Sorry. So usually you calculate limits to answer questions regarding derivatives, but here the logic was a little bit upside down, yes? So here, first, we wanted to use the same idea, but we got stuck. And now we calculated the derivative of this function in a little bit different way. And now that we have the answer, we can compare it back to the original formula, and then we can conclude something about the limits. So you can say that this is an application of the derivatives to help us to calculate a limit. Okay, and then do you remember that I told you that if this a is e, do you remember what was this limit? This limit was 1. Actually, this is the definition of the Euler number. And here, this is also consistent because if you write ln of e is equal to 1. So this is also good to remember that this is also a very important limit. Okay, now let us finalize this because there is also one more formula in the book. And the question is that what happens if you have a, but e to power a constant times x? Okay, so that's also very easy. So the question is now this. If f of x is equal to a to power cx, a should be positive, c is any constant. Okay, so the question is that what is the derivative of this function? But that is also very simple again, yes? So what I can do, I can say that, okay, f of x is equal to a to power cx. What I can do, instead of a, I can write e to power ln of a. and then I have cx. What I have done, I just copied and pasted this part. Instead of a, I wrote this. Okay, but then what I can do, I can multiply these exponents, so it becomes e. I have to multiply this by that. So let me reorganize them. So I would write c first, I would write ln of a second, I put a pair of brackets around them, and then I put an x here. Okay, now if I want to calculate the derivative is the derivative of this function because they are the same. I want to differentiate this function. But now this is a constant. Let me call it capital C. Then I will have e to power capital Cx, and I want to differentiate it. So the capital C goes down, and this function will repeat itself. Yes? So I will do the same thing. So C ln of a will go down, and then the function will repeat itself. But again, this part has a simpler and better name, yes? This is e to power, sorry, this is a to power cx. So if I write them in an organized way, so finally the derivative becomes equal to the function. So c goes down, the function repeats itself, but I also have an extra factor of ln of a. Yes? Okay, so now I want to finalize what we have learned about the derivatives so far. So this is our complete table. So we will not make it more complete this year. You will study this later. So here, if I have a function f here and its derivative here, if my function is constant, the derivative is 0. If my function is x to power c, the derivative is c x to power c minus 1. If I have e to power cx, the derivative is c e to power cx. If the function is a to power cx, the derivative is c a to power cx, but I need to remember to multiply by an extra ln of a. Yes? And then let me write, there are some special cases. I told you that it is better to have them in your memory. If the derivative of x is asked for you, it's 1. If you want to calculate the derivative of 1 over x, the answer is simply minus 1 over x squared. I prefer to remember them separately. That's up to you. The derivative of a square root of x is also a constant. All of these formulas that I am writing here, you don't need to memorize them. You can find all of them all the time using this formula, but because they are happening in many places, so I prefer to remember them separately. And then if I want to write the special cases of this, so e to power x prime is just e to power x. And then if I have e to power minus x prime, I can simply remember this is minus e to power minus x. Okay, so here also, if I ask you what is the derivative of this, this becomes a to power x ln of a. And if I have a to power minus x prime, this becomes minus a minus x ln of a. So here, I emphasize that a is positive. Okay, and c is always a constant. So c in this table, a constant. Okay, and I'll also have different rules. So remember, if I have the sum of two functions differentiate, this becomes the derivative of the first one plus the derivative of the second one. If I have this, it becomes the derivative of the first one minus the derivative of the second one. And if I have a constant multiplied by my function, I don't care about the constant. I just take the derivative of the function and multiply them here. So this is what you have in its full form in Math 3C. So we will not continue completing this table anymore in your lesson. We will continue completing it a little bit in math 4. Okay. Now, just I want to finalize something, is that what happens if you want to calculate a logarithm whose base is neither 10 nor the Euler number using your calculator? So I don't know why they haven't mentioned this formula in Math 3C, but I think it's important. So let me also talk about that. So let me give it a name. Change of base theorem. For logarithm. So this is something I want you to know, even though it is not mentioned in the book. So if I ask you, for example, calculate logarithm of 3, you can just punch this into your calculator directly. If I ask you what is ln of 3, you can do the same thing. But if I ask you calculate logarithm of 3 in base 2, then there is no specific button on your calculator. And the reason is that you can always use the logarithm in base 10 or the natural logarithm to answer that question. But you need this theorem, okay? So let me write this theorem here for you. Roughly speaking, it tells you that if you have logarithm of a in a base b, you can take this into a logarithm in a different base. You can write it as logarithm of a in a base c divided by the logarithm of b in the base c. Yes, but of course you need to respect all the conditions. A should be positive, B should be positive, but B appears as a base as well, so B cannot be equal to 1. C should be positive, C shouldn't be equal to 1. If this is the case, then you have this nice formula. So if you want to calculate the log of A in base B, you can calculate the log of A in another base C, provided that you remember to divide by the log of B in that base C. Okay, I just want to give you the proof here. This is not mandatory, that's up to you if you want to learn this or not, but I think it's very important to know about this. So proof why this formula is working. We had, I think, this in Math 2C together, but if you have forgotten, let us do it here. So I would say let me give names to this. Let me call logarithm of A in base B M. Let me call logarithm of A in base C N. And finally, let me call logarithm of B in base C B capital P. Okay, so let us see what happens. When you say logarithm of A in base B is equal to M, this means that B to the M is equal to A. Yes? When you say that logarithm of A in base C is N, this means that C to the N is also A. So let me see if I have done it correctly. Oh, yes, that's correct. And then when you say the logarithm of B in base C is P, this means that C to the P is B. Okay, so here what I can do like this. I will take this B and replace it by C to power P because they are equal. So let me just write it. So I put C to power P, and then I have a power of an M equals to, you see, instead of this B, I put C to power P. And there is an M here, so I put that M there. Instead of this A, I put C to power N because they are equal. Okay, so this becomes C to power N. On the left-hand side, I can simply write C to power M times P. And on the right-hand side, I have C to power N. But this is also easy now because the bases are the same and they are supposed to be equal. So this means that the exponents have to be equal. So it means that MP is actually equal to N. Yes? But then if I divide by P, I get M equals to N divided by P. But now let us write these things back. What was M? M was this log. Okay, so instead of N, M, I put the same log. Now on the right hand side, instead of N, I can put this, and instead of P, I put this, and I am done. Okay, so that is the change of base theorem for logarithm. But usually two versions of this are very interesting. So for example, let me write that formula. Let C be equal to 10. Okay, C should be positive and not equal to 1. So 10 is acceptable here. If I write C10, what happens? This means that logarithm of A in base B can be written as logarithm of A in base 10. I am choosing 10 for C. Base in divided by logarithm B in base 10. But do you remember the convention? When the base is 10, nobody writes that. So it is simply log of A divided by log of B. So it's a very nice formula. So this is why you don't have this button on your calculator, because you can use the log button together with division button, yes? So you can immediately calculate this. So this is something that you need to know. If you want to use your calculator to calculate a log in a different base, another choice that people usually make it easy, so they choose C equal to E. C can also be equal to E, yes, because C should be positive and not equal to 1, and this satisfies those conditions. So then what happens? Then so let's, if this is the case, then log of A in base B is equal to log of A in base E divided by log of B in base E. But I told you nobody writes log of A in base E. There is a shorthand notation for that. It's called ln of A divided by ln of B. So it doesn't matter which buttons are you going to use on your calculator. You can use the base 10 button or base E button, but base E button is just simply ln. So both of them are correct. So this is why you don't need to be worried about calculating a log in a different base using your calculator. So I think this should be somehow mentioned in Math 3C, but it is not anyway. So that is something that I want you to know. Okay, so one more thing that I just want to mention and we finalize is the graph of e to the power of x and e exponential, so ln function. So it's good to know that. So if I want to draw the graph of e to power x, because e to power 0 is 1, so it means that if x is equal to 0, this should be 1. And then if x is very big but negative, it approaches 0. And if x is positive and very big, it approaches infinity. So so let me just draw the graphs, and then if you have questions, I can answer you in the next session because we don't have that much time. So the graph is something like this, and it goes up very fast. Okay, so this is the graph of e to power x, but ln of 1 is 0, so this means that ln should pass through this point. So let me change the color now. So the ln function is the graph of the ln function is something like this. But if I draw them carefully, they should be mirror image. This, of course, doesn't work. I need to use GeoGebra. Might be I will do it next time. So if I draw the bisector here, so let us see, this is y equals to x. If I draw it very carefully, so this is the graph of y equals to ln of x. If I draw it carefully, these two, the graphs would be mirror image of one another with respect to this. If you consider this as a mirror, then these are mirror images of one another. So let me put this point is 1, and then this point is also 1 here. Okay, but we can talk about this a little bit later. And this is the x-axis and this is the y-axis. Okay, I think it's a good point to stop. So, but I will give you some examples next time, and then we are actually done. Any questions so far?
Could a question about the proof come up on the test?
On the test, no. Even I don't give questions that needs this formula, but this is some extra information for yourself. How, if you want to calculate the log in a different ways, based using your calculator, what you need to do. This is the way that you need to do it. This part, let me write here. Optional, okay? Yes. Any more questions? So I will upload the video onto the YouTube channel. It takes a little bit time, and then I will put this the notes, the lecture notes, both in the Google Drive and below the video that I will upload onto the YouTube channel. Okay, if you don't have any questions, we can stop here. Okay, thank you.
Bye.
Thank